Hi there, everyone. Thanks for coming. Hope you're all still bright and breezy at this time of the day. Not too desperate for lunch yet. So I'm going to be talking about kicking off background tasks mostly on mobile devices, starting off with UWP, Windows 10, and then moving on to iOS and Android with Xamarin. Just out of interest, how many of you are already using UWP? All right. And how about Xamarin? Oh, that's a pleasant surprise. I'm in the right place. So I'll start off by covering what it is I'm going to be talking about. Is it kicking off a background task? Is it just multi-threading in general? And what is the distinction? I'll then talk a bit about some general concepts. Things that are going to be common across the platforms, even though there will be slightly different implementations of them and nuances on each platform. And we'll then dive into options on UWP, options on iOS, and options on Android. So let's get straight into background tasks versus threading. And here I'm talking about just using things like await and async and making sure you're running things on different threads, not blocking the UI thread. I've got there, that's critical for heavy processing. I'm not an enormous fan of doing this too often, but I'll put it on the heavy because really you shouldn't be doing anything heavy at all, any heavy lifting on the device. That should all be offloaded to your back end. But it does still happen. Now, whether you're writing an enterprise app or a consumer app, your app is going to be sitting alongside other world-class apps, and your users are not going to be forgiving if your app is not responsive, if your UI is not responsive. And I don't mean there it resizes nicely when you switch to landscape. I mean something happens when you poke it. So we can use async await, supported by .NET, supported by Xamarin on all platforms, as most of you will know, because lots of hands went up. But what I'm going to be talking more about here today is what do you do if you want to kick something off and ensure that that's going to run to completion even when your app is shut down? Or what if you just want something to continue running in the background even when your app is shut down? And what are the mechanics of that on each of the different platforms? So I'll start off with some of these common concepts that I mentioned. Now, I'll talk about tasks a lot this morning, and I'm not talking about system.threading.tasks. I'm talking about a finite piece of processing that you want to execute. Then I'll have the concept of a foreground app. That's defined as the app that's currently on display, that currently has the user's attention, and currently has access to as much of the local device resource as is possible. We've then got a suspended app. That's when your app is interrupted by something else. Something else comes in and just grabs the user's attention, and your app is pushed to the side, either momentarily or longer term. Typically, an app in this state would remain in memory, but it's not going to get a huge amount of resource allocated to it. You can hook into when this happens and just perform some basic app housekeeping, saving states, maybe saving a bit of data or trying to upload something. And then we've got a background app, which is an app that's running in the background. So let's start off looking at UWP. What options does that give us? Well, in each of the platforms, I'm going to touch a little bit on some lifecycle events so that we know what kind of things we should be hooking into, where we can be kicking things off, where we should be tidying things up. So who remembers Windows Phone 8? One or two. So these were some of the application lifecycle methods here. And then moving into UWP, we get these event handlers that we can hook into. So this starts suspending, where we might try and get some extended execution time to save state, and this starts resuming, where we might want to load the state. That's when you receive a phone call, you finish your phone call, you switch back to the app. Now, there are two different approaches on UWP. There's extended execution and there's a full-on background task. So we'll take a look at extended execution first. And this is something that was, we'll see some code in a moment, but this is typically where you put something in that on suspending event handler, and you have to request permission to perform some extended execution. You have to request some extended execution time. And it's important when you're looking at that to bear in mind that the answer might be no. And if the answer is yes, you might then think, okay, great, I can do some extended execution, and you've just started and it gets revoked. So you've got to handle these things cleanly. So within the extended execution, again, split it down into two types. The first just requests a bit of extra time while it's before the app actually goes into the suspended state to do something. And the second just lets the operating system know we want to carry on running. Beyond that, we're a special kind of app. And critically, neither of these has any UI, so it's all happening behind the scenes. So this is where it gets interesting. Is that clear at the back? I'm not seeing any nods. Do I need to try and make it a bit bigger? So I'm going to be calling out a few things in this. Oh, it's a bit too big, but okay, so the important thing is, apart from being a little bit blurred, we've got this code in the onSuspending event that I mentioned earlier. So this is called as the app is entering the suspended state. And the next thing, sorry, bear with me while I zoom in and out. Where's my pointer gone? There we go. Next thing we're doing is calling get deferral. So we first have to let the operating system know we're going to be doing something at this point. This isn't where we're requesting permission to perform some extended execution. We're just letting the operating system know that we're doing something. And if I can scroll smoothly down a bit, the last thing we do is tell it that we've finished. And that we have to do cleanly to be a good citizen on the device. So here, I'm trying to zoom in and out. I'm worried about making anyone car sick. Is it working zooming in and out? Or shall I stay in, stay out? Any preferences? Stay out, I heard? Okay, all right, I'll read things out just in case people are struggling to see at the back. So what we've got here is we're creating a new extended execution session. This is where we're beginning the process of requesting permission for extended execution. And you'll see that we're supplying a reason and a description. You have to give both of those things in order to stand a chance of getting a positive response. And the reason, we're using the extended execution reason enumeration and supplying a reason of saving data. You can also do things like location tracking. It's also possible to give a reason of extended execution reason dot unspecified. If you do that, you probably shouldn't expect the request to be successful. Just quickly, is this request just to the OS or is it to the user? To the operating system, yeah, not to the user. Thanks. So the next thing you can see we're doing here is wiring up a revoked event handler. So this is to kick in if we do get permission for the extended execution, but then that permission gets revoked. If we want to do any tidying up, that's where we would need to put that. And this is where we're actually performing the request. So we do await session.request execution async. and we can get one of two responses. We either get allowed or we get denied. Now in this example, if it's allowed, then I'm working on the assumption there's a bit of extra time, and I'm just doing a wait, send all data. So this is assuming that you've got a bunch of data that you'd like to send. If you get permission, you want to send it all. If you don't get permission, you'll try and just send a small amount. So I've got there, if the result is denied, then I'll just send summary data. So that covers the first type of extended execution that I mentioned. What about the second type? So here we were talking about telling the operating system we're a special kind of application and we want to request some extended execution time. This is largely the same. We're still creating a new extended execution session, giving it a reason and a description, still giving it a valid reason rather than unspecified, and then wiring up the revoked events to handle if I get permission, but then the permission is taken away. And the remainder of the code, you can see, is also the same. The main difference is this is sitting in its own method that we can call at any point in our application, rather than something that just kicks in as the app is suspending. And here's the bits that I've just pointed out. Okay, so that covers briefly the concept of extended execution, the need to request permission, the need to handle permission being denied, the need to handle permission being revoked if it was granted. So let's take a look at a full-on background task as opposed to the extended execution. So a background task we can attach to a system event. We need to write the background task class in such a way that we can register it with system events or triggers. And there are a number of available triggers that we can attach these things to. They look a bit like this. So you can attach, for example, a background task to if an SMS is received, if the internet becomes available, or if the time zone changes, or any of those operations. Okay, that is a bit too small, I think. So the first thing I need to do is write a class that implements iBackgroundTask. And that brings a couple of things in for us. First one being a run method that accepts a parameter of an iBackgroundTask instance. So as before, the first thing we need to do is say get deferral. We're telling the operating system we want to do something. And again, when we've finished, we'll call deferral.complete, tell it that we finished what we're doing. And again, as before, similar to wiring up a revoked event, we need to wire up a cancelled event to handle that permission being revoked. Now we're also doing a little bit more here, and I'm going to just quickly zoom into this bit and then back out again. So apologies for the in and out. But what I'm doing here is checking the current background work cost and making some decisions about what processing I want to do, basically depending on what resources are available. So if the current background work cost is high, then I need to assume there's not much resource available for my app, so I'll just perform high priority operations. If the current background work cost is medium, I'll maybe get a bit more, the ability to do a bit more. And if the current background cost is low, I can go for broke. You'll see mention of current background cost in a moment as well when we actually start attaching this to a trigger and attaching some conditions to that. quite a bit smaller than I expected. So here, we're going to register with a system event. So we've written our background task class, making sure we implement that interface. And here, the first thing we need to do is be a good citizen and check whether or not we're already registered with this event. So we'll take a look at background task registration.all tasks and just have a look in there to see if this registration has already taken place. We don't want to go eating up resources unnecessarily and repeatedly registering something when we don't need to. So that's where we're checking that. Then we're creating a background task builder. And again, you'll see we give it a name and a task entry point. So the task entry point takes the format namespace dot the class that we want to be instantiated and called into when this system event occurs. And in addition to that, we'll then call setTrigger to say we're going to attach this background task to when the internet becomes available. So if the operating system registers that the internet is now available, it'll call into our app and kick off this background task and do whatever processing we're looking to. The second parameter there, the false right at the end, that is telling the operating system that this is not a one-off association. We want this to be triggered every time the internet becomes available. Depending on what you're trying to do, that may or may not be a good idea. Below that, I've got two lines that say add condition. So this is adding two conditions to this trigger. And we can look at system condition type to see what is available for us to add. And here, as well as adding wiring up to the internet available trigger, I'm specifying that I only want the background task to be kicked off if the free network available is set, i.e. it's Wi-Fi, and if the user is present. So rather than always kicking off this task every time the internet becomes available, it will only trigger it if those conditions are met. And then finally, that bottom line actually performs the registration once we've set it up in this way. And those are the other conditions that you can set. So is the user present? Yeah, and yeah, this is where I mentioned earlier, you can check background work cost not high. So you can also say, okay, I only want my background task to kick off if there are resources available. I don't want to then go adding to an already overloaded device. Okay, now the last thing for UWP is if we've kicked off a background task like this, how do we get anything back from it in our app? What we can do is wire up our background task completed event, and when our app is launched or resumed, if the background task completed while it wasn't running or while it was asleep, this will be fired when it comes back, when it becomes a foreground task again, and we can go and query the result and do what we need to with it. And the last step as well is those enumerations, the different things you can attach a background task to. They need to be declared in the app manifest, otherwise any attempts to register a background task with them won't succeed. So that's a bit on UWP, looking at extended execution versus an actual background task kicked off by a system trigger. Now let's take a look at what we can do on iOS using Xamarin. So again, I'll start off just touching on some of the life cycle. and the 5 different states that iOS can tell us about. And the first one is not running, which is not difficult to figure out what that means. Inactive means the app is running, but it's not receiving events. So in practice, apps transition through this state on their way to another one. The active app, based on the 3 definitions I had right at the start, this is the foreground app. This is the one that has the user's attention at the moment and the lion's share of the resources on the device. We've then got a background task or background app, which means it's currently registered to run in the background. And there are some constraints that apply to this on iOS that I'll come to shortly. And then lastly, again, as mentioned at the start, a common concept of a suspended app, an app that resides in memory. It hasn't yet been completely trashed, but it's not considered currently running. So has anyone done native iOS development? Okay, so half a hand, I think. So on iOS, if you're looking in Objective-C, you've got a number of delegates that you can write that will get called at various stages in the application lifecycle. So these are on the left. But I'll take one example that did finish launching with options. The middle column shows how we can hook into those using Xamarin. So on xamarin.ios, we can write a method with those names in the appdelegate.cs. So did finish launching with options maps to Xamarin's finish launching, and that's typically where our initialization stuff goes. If you've used Xamarin Forms, that's where Xamarin Forms gets initialized. It's also where you might just add a reference to a third-party component to make sure the Xamarin build process doesn't strip it out. And that's one example where you have 17 seconds to return, otherwise your app gets killed, which is very frustrating when you're trying to use an old iPad 2 still. Everything gets killed. So where we talked about extended execution and background tasks on UWP, we've got similar concepts on iOS. We've got finite length tasks, which is a task that has time constraints but no resource constraints. If you don't finish within the allotted time, that's it, you just get shut down. We then have long-running tasks, which don't have the time constraints, but they do have the resource constraints, and we'll get into that a little bit more. For example, you can use these to play or record audible content. As soon as the audible content stops, if you're playing something, as soon as that finishes, then your app will become suspended and it will no longer be a long-running task. And then there's a separate one, downloading content, designed for data transfer only. Again, not time restricted, and will continue if your app is terminated and will wake your app up on completion. So we'll take a bit of a look at the first two. And first of all, finite length tasks. So remember, these are time constrained, not resource constrained. So if we want to start one of these on iOS, that's fairly straightforward. We call UI application.begin background task, and we pass in a delegate, which is a method that gets called if that time, the allotted time, expires. And that's where we'd have to clean up. At any point in there, we can query the amount of time that we've got left by looking at background time remaining. Now, if you're coming from .NET land, which I expect we all are, you'll expect that to contain milliseconds, and you'll be surprised because it contains seconds. And then the last thing we need to do, again, to be a good citizen on the platforms, clean up after ourselves, make sure we end the background task, either when we're done or when the time expires. In fact, these are 4 cases where we need to manually end that background task. If we complete successfully within the allotted time, if the task is cancelled for any reason, the time runs out, or if the app that triggered it comes back into the foreground. So I've got some code here. I should probably stop apologising for how small it is and just carry on. But you'll have access to all of the slide deck afterwards. And if you want access before it's available to download on the website, just come and grab me after the talk. So I'll just walk through what we're doing here. So the first thing we're doing is similar to that line I showed you just now, where we're kicking off this finite length task. Just got task ID is UI application.shared application.begin background task. And remember, this is where we were passing in a delegate method that would get called when the time expires. In this example, I've just shown how to do that in line rather than as a separate method. So within the task, I'm checking whether or not cancellation has been requested. And there I can make sure that I neatly end the task if it has for any reason. And I can also throw a specific type of exception, which is throw if cancellation requested. And that will get picked up as an operation cancelled exception, and again can be handled neatly and make sure the task is shut down. And then the last step is to wire up one of those lifecycle methods that I spoke about earlier. So this will be an appdelegate.cs, and I'll override will enter foreground. That is when the app is about to come back into the foreground, and again we want to make sure we end the background task at that point. Okay, so that's a bit about finite length tasks on iOS. In some ways similar to extended execution on UWP, and now we'll look at long-running tasks on iOS. Now remember, these are not time constrained, but they are resource constrained. There's only certain operations we can perform using these. And the operation that we want to perform has to be registered in our info.p list. So these are the possibilities. We can kick off something to continue playing audio after our app is shut down. We can carry on tracking location. We can have something for voice over IP, and there's various other options. Continue to communicate with a Bluetooth LE device, and a number of other things. So we'll take a look at a handful of those. So if we touch on audio to start with, the media framework on iOS, if you've registered to do this, will prevent the app from going into the suspended state while media content is being played, or if you're recording while it's being recorded. As soon as that completes, then control is handed back to the operating system to carry on as if nothing had happened, and it will continue with the app suspension. Voice over IP, in practice at a higher level, kind of similar. At a lower level, it's not actually preventing the app from being suspended. So your app will be suspended, but the operating system will continue to monitor sockets for inbound communication. And if that happens, your app will be brought out of suspension and your code will be executed. So fetch we'll take a little bit more of a look at. This is something that we've used to fetch new content. If I think of an example of a public transport app, and you want to check whether or not there have been any updates to the train timetables. I'll talk about that happening at an interval of half an hour in a moment, and for the New South Wales app, it seems like they do actually get updated that frequently. So what we can do here is register to say we want to fetch data periodically. The operating system will decide how frequently that happens, and it might decide that it never happens, but we can register and request it. So it's going to make decisions based on the equivalent of that background cost, what resources are available. So if and when a fetch operation is triggered by iOS, the app is launched in the background using perform fetch with completion handler. that's the iOS delegate that kicks in. Xamarin provide access to that with the perform fetch override. So you'll see here, the first thing we're doing is declaring the fetch result. And what we have to do is return a valid value in there as quickly as possible. So there's no code in to actually go fetch data, but assuming that there is, if it works, we then set fetch results to new data, meaning new data has been received. If there's an error, we set it to failed, and then we call the completion handler and pass in that result that we've just set. Now, I talked about iOS deciding how frequently to trigger this based on resource load, and the fact that it might decide not to trigger it at all, or rather just might not decide to trigger it. You can exert a bit of control over this by setting a minimum background fetch interval. Now, again, this is in seconds and not milliseconds. So if you specify this in what you think is milliseconds, you're going to be waiting a long time before it kicks in. When setting that, there are a couple of constants that we can use. We can use background fetch interval minimum, which basically means we want this to kick in as frequently as the operating system will allow. If you go and try and research exactly what that figure is, I know I couldn't find a published figure, but a general consensus that it's around the 10-minute mark. You can also set it to background fetch interval never, which effectively switches it off. So within your code, you can switch this on and off by using that. So I mentioned as well arriving at a decision on what that result is going to be. Did your operation perform successfully or not? And returning that as quickly as possible. If you want to increase your chances of being called by the operating system, you need to make sure that you're returning that as quickly as you can, and ideally within about 30 seconds. That'll just kind of put you up the list a little bit. So that's the different options that are available to us on iOS. And you'll see already some of the nuances and distinctions and things that you have to do slightly differently, even if it's just things with different names on the different platforms. So now let's take a look at Android. Is anyone coding for Android with Xamarin? And how about iOS? Okay, about an even split. I didn't check if it was all the same people. So Android gives us 4 states, where iOS gave us 5. Again, running, similar to is running, fairly self-explanatory. So yeah, running, an activity is opened by a user. Paused is when an activity view is either completely or partially obscured. There's then backgrounded, which means the home button's been pressed or the app switcher has been triggered. And in this state, the app is still in memory. And then there's stopped. It's not running at all. You've either come out of the app or the operating system has shut it down because it's low on resources. It's running out of memory. So in Xamarin, we have a number of things we can override for the hooking into the lifecycle events on Android. When I say a number, there's a fair few. Yeah, that's the last one. Some of those are reasonably self-explanatory, where they happen, where you can expect them to be called. But it is useful just to write an app with nothing in it except overrides for each of these and some method of logging so you can figure out what's happening when, and then run the app up and do various things, phone yourself and switch to other apps and figure out exactly where each of them is happening. And this is what you'll come out with. So when the app is launched, you can expect on create, then on start, and then on resume to all be called. Pause and resume are what you'd guess. When the app is backgrounded, on stop is fired. Again, on restart, fairly self-explanatory. And when a backgrounded app is stopped, on destroy, it's fired. Now, if we want to do background processing on Android, we've got to become familiar with Android services. So this would be part of an application that performs a long-running task without a UI, similar to the definitions we've seen on the other platforms. Oops. Excuse my animation ordering. There we go, everything's there. So if we want to write an Android service class, the first thing we have to do is, there we go, implement the abstract class android.app.service. As we implement that, we'll get an onBind override that we'll see cropping up a few times, and then we'll dive into that a little bit more. And we also want this decoration up here, android.app.service, outside the class. When we put that there, Xamarin does a bit of work on our behalf. When it sees that, it then goes and registers this class in the manifest for us. Now, bear these things in mind at the bottom as well. They'll be familiar to you based on what we've talked about on the other platforms, if they weren't already. But as the device starts to run short on resources, it'll look for things to shut down. It'll shut down activities first, but it will move on to services. If your service is shut down, the way that you set it up will determine whether or not it attempts to restart automatically when resources become available again. So now that we've declared that service class, defined it as an Android service, how do we start it? Is it nice and easy like this? Well, not quite. Trying to think off the top of my head something that is nice and easy on Android. So you need to start it via an intent. And specifically make sure you've got an onStart command override in there, and that will get triggered when you start with an intent. And we'll look a bit more at this in a moment. You'll see that this onStart command is returning, return onStart command. Okay, sorry, it's not obvious yet. But we want to return a value there, and that value is what determines what happens to our service if it does get killed by the operating system. So if we define it as not sticky, if the service gets killed, that's it, nothing automatic happens. And this would typically be for something that you can run repeatedly without adverse impact. Maybe it's downloading an update. We've then got redeliver intent and sticky. So both of those will cause the service to attempt to restart automatically once resources become available. And the first of them will pass in the intent the same way as it was when we first called it. And then we've got sticky compatibility, which is designed for pre-API 15 to get Android services to try and restart automatically. Now, if we do that, we can't guarantee that that onStart command will be called, but we can at least try for the older devices. Oops. Let me just point out that last one as well. Again, it's important that onStart command returns one of these values as quickly as possible, similar to iOS, which basically means as you come into that, you'll want to kick off a separate thread and then return that value quickly, and your separate thread will be what's doing the processing. So once we've got all this defined, we can start and stop the service class like this. Using an intent. So we can create a new intent and then specify the service class that we want to kick off. But what if you want to kick off a background service but still communicate with it from our app? Maybe you want to track location. We want location tracking to continue if our app is shut down, but if our app's running, we want to be able to reflect what we get back from that location tracking in the user interface. Sorry, it's just an alternative way of stopping a service from within itself. Okay, so when it comes to wanting to communicate with these Android services, this is where we come back to the binding and the on-bind that we saw earlier. So with Android, we can bind to the service, and the operating system will shut down the service when everything that has bound to it has unbound from it. So here's that scenario I just mentioned. We want an app that tracks location, shows the location in the user interface. We want to start the service when the app's launched. We want to communicate with the service so we can display the location. And we want to leave it running when the app is terminated. So we start off by creating a service class. So that would be android.app.service. So inside here, in this example, I'm declaring a timer to kick off once a minute. And if I look at start command, so you'll see here in the start command section, I'm wiring up the elapsed event for the timer, starting it, and then straight away I'm returning start command results.sticky, which means, as we saw earlier, if the operating system shuts this down, it will restart it. So this is where it gets a bit involved with Android. So we saw we get this on-bind override. Now to use that, we have to set up the service binder here. Now that we need that in order to interact with the service, and the binder object that we're setting up here will contain a reference to the service. Ahead of myself a little bit. So all we're doing there really is exposing a property that we can use to get to the service. Now this kind of takes walking through a few times to properly get your head around it if it's all new to you. We also have to set up a service connection. And for that, we have to implement the iService connection interface. And when we do that, these are the methods that we get as a result. So onService connected, onService disconnected, and then handle and dispose. Those last two, I can simplify things a little bit by inheriting from java.lang.object. And that will sort out those last two for me. So the next point of interest in here is onService connected. So this will be called by the operating system, and it saves the service binder that's passed in, and then fires a connection changed event. Now for that we need the service event args that we've got specified here. Now that just provides a way of indicating whether or not the service is currently connected. And then in onService disconnected, we can do the same thing down at the bottom here. and just specify false to say the service is no longer connected. The last step is for us to use a service manager class, and that's going to handle creating the service, starting the service, and binding to it. And you'll notice in here that the service itself is started on a separate thread. So then we'll create the intent, start the service, and bind to the service. Now here's some code that can go in your main activity.cs in the Android project. And this is where we can see, are we connected? If we are, then wire up the timer elapsed event. If we're not connected, then neatly unwire it so we don't leak any memory and leave anything hanging around that we're not supposed to. And then in the timer elapsed event, we put something here and do whatever it is we actually want to do when the thing kicks off. So a fair bit to digest there, and a lot of detail. I've mentioned here some of the other lifecycle events where we should also be tidying things up. If I take the example of pause and restart, on pause we should really be unwiring that timer elapsed event so that it's not trying to trigger when the app is suspended. And then on restart we should be wiring that back up again. So whistle-stop tour of the three platforms there and diving into quite a bit of detail. So UWP, we looked at extended processing versus background tasks, the distinction between them. iOS, we had finite length tasks versus long-running tasks. Again, similarities between those. And then Android, it's all about the services and binding. So I've reached the end of what I was going to walk through. Are there any questions anyone wants to throw at me? May or may not be simple answers. You might need to chat afterwards rather than give a quick one-liner, yeah? Yes, you can. Yeah, come chat to me afterwards. We'll look that up and see if you want some more info, but yes. Yes. No. Again, it can be quite subjective, and if you're wanting to use that and rely on a certain amount of time, you'd have to go through a bit of testing and see if what you're actually getting is sufficient, or do you need to actually cut back on what you're trying to do. I don't know that, again, that there's an instant answer that is always going to be in that ballpark. Yes, yeah, do as little as possible, but there are times where you do want to at least save state so that you can load state again when your app resumes. Yep. Okay. You'd be putting this into the platform specifics, but there are some Xamarin Forms lifecycle events that you can trigger those from. So you can share some of the concepts, if you like. But again, because you want to make sure you're not leaking any memory, you're not leaving any resources in use, you'd want to walk through what you're doing and make sure that that's mapping down at a platform-specific level to what you're expecting. You could call back into that, yeah. Yeah, it depends if what you're doing is platform specific or not. Okay, well, I'll just put up a couple of slides right at the end. There's some great resources if you want to carry on finding out more. I suspect you may have seen these in previous presentations. I quite fancy one of these drones. So especially if you like the presentation, fill out an evaluation. And then remember to collect your wristbands at one of those locations. I'll hang around for a short while here. I've got a talk this afternoon as well that's not on Xamarin. But if you see me around and you want to ask any questions, just grab me, and I should be at the event tonight as well. So thank you very much.